In 1977, the greatest adventure in space exploration commenced.
We have ignition and we have liftoff.
Our eyes, our minds, our souls are moving out through the universe.
Since then, NASA's iconic twin Voyager spacecraft have upended what we think we know about the vast universe. They visited mighty Jupiter, ring-bedecked Saturn, gloomy Uranus, and stormy Neptune to lay bare humanity's naked insignificance. The brutalized moons, ring particles clinging to million-mile racetracks, sulfur-belching volcanoes, ice-spewing geysers, craters straight out of Star Wars, and roiling Earth-sized tempests the Voyager saw captivated us with an exquisitely savage beauty. In recent decades, the missions have made few headlines, but the little spacecraft have continued voyaging outward beyond the wildest dreams of scientists. And now, after nearly a half-century in space, at a distance of more than 157 times from our planet to the Sun, humanity's most faraway spacecraft is still sending back some shocking data from interstellar space that's leaving NASA engineers scratching their heads.
Turn around and take a picture of all the planets in the solar system, and I thought that this would be a riveting collection of images, a first.
Join us as we get to the bottom of everything that happened and consider what the discovery means for the future of humanity. Renowned as a big science endeavor that consumed some 10,000 work years, NASA's Voyager mission has been described as one of the greatest voyages of exploration ever conducted by our species. But few people are aware that it almost didn't happen. The prospect of a grand tour of the outer planets emerged in 1965 from the musings of an aeronautics graduate student named Gary Flandreau, then working part-time at NASA's Jet Propulsion Laboratory, JPL, in Southern California, the world's preeminent center for interplanetary exploration. At age 6, Flandreau had been given Wonders of the Heavens, a book that showed the planets lined up like stepping stones. I thought about how neat it would be to go all the way through the solar system and pass each one of those outer planets, he recalled. Assigned at JPL to envision possible missions beyond Mars, Flandreau plotted the future positions of Jupiter, Saturn, Uranus, and Neptune with paper and pencil. He found that they would align in such a way that a spacecraft could tap the planet's orbital momentum to slingshot from one to the next, gaining enough velocity to visit all 4 planets within 10 or 12 years, rather than the decades such a venture would require otherwise. The mission launch window would open for a matter of months in the late 1970s, then close for another 175 years. It was an ambitious idea at a time when the apex of interplanetary exploration was Mariner 4 shooting 21 grainy photos as it flew past Mars. No probe had ever functioned for anything close to a decade in space. None had the intelligence to manage complex planetary encounters at vast distances without constant human hand-holding. Playing crack the whip past multiple planets might work in theory, but had never been attempted in practice. I was told, "This is impossible. Stop wasting my time," Flandreau recalled. NASA swallowed hard and proposed a grand tour mission anyway, but Congress rejected it, instead approving a cheaper, stripped-down version that would venture out no farther than Saturn. The JPL spacefarers responded in the tradition of the hardiest explorers of earlier epochs. They cheerfully agreed to the plan, assured one another that Congress didn't really understand the situation, and quietly went to work designing and building 2 tough, smart spacecraft capable of going all the way to Neptune. Any life-limiting flaws in the probe's design were weeded out. The sun sensors in their navigation systems were boosted so they could function out where the sun gets dim. Fuel-saving techniques were developed to keep the mission viable long after it was supposed to end. "We just did it and didn't talk about it," recalled William Pickering, JPL's director at the time. The ruse worked. On August 20, 1977, 46 years ago, an extraordinary spacecraft left this planet on a journey like no other. Voyager 2 was going to show us, for the first time, what the outer solar system planets looked like close-up. It was like sending a fly to New York City and asking it to report back. Voyager 1 was launched after Voyager 2 on September 5th. Attached to the flank of each Voyager was a golden record carrying greetings, sounds, images, and music from Earth. Each about the size and weight of a subcompact automobile, the Voyagers epitomize 1970s high-tech. Their computers are weaker than those in today's digital watches, their analog TV cameras more primitive than the ones that shot Laverne and Shirley. But they made history at every planet they reconnoitered, confirming, as Voyager chief scientist Ed Stone put it, that nature is much more inventive than our imaginations. The twin craft swept past Jupiter. Voyager 1 reached the gas giant on March 5, 1979, and Voyager 2 arrived on July 9, 1979. They discovered dark rings made of tiny, rocky grains, whilst time-lapse movies of the famous Great Red Spot unmasked the centuries-old, counterclockwise rotating, Earth-sized hurricane. They surveyed Jupiter's moons, pegging the diameter of Ganymede at some 3,300 miles as the solar system's largest natural satellite. Tantalizing hints of water on Europa and volcanism on Io whetted the appetites of scientists and the public alike. But these tours were, by necessity, only whistle-stop in nature, and the crafts quickly left the gas giant behind. In November 1980 and August 1981, Voyager 1 then Voyager 2 encountered Saturn. This visit garnered a more accurate measurement of its day, at 10 hours 39 minutes, and the discovery of some of the solar system's nimblest wind speeds, 1,100 miles per hour, near the equator. They detected new rings, measured ring particle sizes from around 0.4 inches to 50 feet, and found tiny shepherd moons which kept ring material rigidly in line. Voyager 1 got a close look at Saturn's moon Titan when it flew within 2,500 miles of the world, revealing a thick nitrogen atmosphere. The missions also captured views of Saturn's other moons, including peculiar two-toned Iapetus and icy Enceladus, whose 95% albedo makes it the solar system's brightest moon. After Saturn, the two spacecraft took divergent paths. While Voyager 1 departed the ecliptic plane, Voyager 2 aimed for two new worlds, a decision made in January 1981 and aided by a course correction at Jupiter. In January 1986, it passed Uranus, a seemingly bland planet with an odd axial tilt of 97.77 degrees. However, Uranus's sedate appearance proved misleading. Powerful magnetism, strong aurorae, and intense radiation darkened its moons, including coal-gray Umbriel, which sports a crater that exhibits a bright ring of material, referred to as the fluorescent Cheerio. 10 new moons were discovered, but Miranda stole the show, its tortured surface hammered by eons of meteoroid bombardment and tectonic upheaval. In August 1989, Voyager 2 flew just under 3,000 miles over Neptune's North Pole, closer than any of its previous encounters, then swung south to inspect its moon Triton. This revealed the solar system's coldest known surface at nearly 400 degrees Fahrenheit, 236 degrees Celsius, with thin clouds and curious geyser plumes rising to 5 miles above the surface. During its quick visit, Voyager 2 found new moons and rings around the ice giant, and like its twin, Neptune proved unexpectedly active, its atmosphere punctuated by an Earth-sized storm, the Great Dark Spot, and a fast-moving plume, the Scooter. But Voyager offered few insights into how a world so far from the sun generates enough energy to power such dynamic weather. After this final planetary flyby, the twins turned their attention to finding the very edge of the solar system. In December 2004, magnetic data indicated that Voyager 1 had possibly passed the termination shock, where the solar wind slows from millions of miles per hour to 250,000 miles per hour in response to external pressures from interstellar plasma. Later, the team declared that, at 8.7 billion miles from the Sun, Voyager 1 had entered the heliosheath, the region beyond the termination shock. Voyager 2 entered this region in August 2007. By August 2012, following an uptick in galactic cosmic ray measurements, Voyager 1 crossed the heliopause, where pressures from the solar wind and interstellar plasma fall into equilibrium. At that point, the probe was about 11 billion miles from Earth. Voyager 2 followed suit in November 2018. "We can now answer the question we've all been asking," said Voyager project scientist Ed Stone at a press conference called to announce the discovery. "Are we there yet? Yes, we are." 46 years on, Voyager 1 is 14.49 billion miles, and Voyager 2 is about 12.95 billion miles away from home, zipping outbound at over 38,000 miles per hour and 34,000 miles per hour, respectively. Both Voyagers are now so far from Earth that a one-way radio signal traveling at the speed of light takes almost 22 hours to reach Voyager 1 and just over 18 to catch up with Voyager 2. Every day, they move away by another 3 to 4 light seconds. Their only link to Earth is NASA's Deep Space Network, a trio of tracking complexes spaced around the globe that enables uninterrupted communication with spacecraft as Earth rotates. As the Voyagers recede from us in space and time, their signals are becoming ever fainter. Although faint as they are, those whispers have upended astronomers' expectations of what the Voyagers would find as they entered the interstellar phase of the mission. As of now, the Voyager spacecraft are the only active human-made objects to have ventured into interstellar space. This achievement is monumental because it marks the first time that any spacecraft has been able to explore the region beyond the influence of our sun's solar wind. For decades, the study of interstellar space had been relegated to theoretical models and indirect observations. But with the arrival of the Voyagers in this uncharted territory, our understanding of the space between the stars is rapidly evolving. The two Voyager spacecraft have provided invaluable data that has fundamentally changed our understanding of how the interstellar medium, the diffuse matter that exists between the stars, interacts with the solar wind. The solar wind, which is a continuous stream of charged particles, mainly electrons and protons, flows outward from the Sun, creating a vast bubble known as the heliosphere. This heliosphere extends well beyond the orbit of Pluto and serves as a protective shield for the solar system, helping to deflect much of the harmful cosmic radiation that permeates interstellar space. The study of the solar wind and its interaction with the interstellar medium has long been a subject of interest for scientists, and the Voyagers have provided the first direct measurements of this phenomenon in interstellar space. These spacecraft have essentially allowed scientists to observe in real time how the solar wind behaves as it interacts with the material in the space between the stars. This has given researchers a new perspective on the dynamics of the solar wind, how it shapes the structure of the heliosphere, and how it is affected by the interstellar medium. The observations made by the Voyagers have confirmed that the heliosphere is not a rigid, unchanging structure, but rather a dynamic system that is constantly influenced by external forces, such as the magnetic fields and the particle densities in interstellar space. One of the most significant contributions of the Voyager mission has been the provision of information about the heliosphere itself. This region of space, which is created by the Sun's solar wind, acts as a protective bubble for the solar system. The solar wind carries with it the Sun's magnetic field, creating a vast magnetic bubble that shields the planets and other objects in our solar system from much of the harmful radiation and energetic particles that populate the space between stars. The heliosphere is not a perfect sphere, but rather it has a somewhat irregular shape, influenced by the solar wind's interactions with the interstellar medium. These interactions have been observed and documented by the Voyagers, offering new insights into how the heliosphere functions and how it is shaped by the surrounding space. As the Voyager spacecraft continue their journey through interstellar space, they are also providing data on the outermost boundary of our solar system, known as the heliopause. The heliopause marks the point where the sun's solar wind pressure is no longer strong enough to push back the interstellar medium. It is the boundary between the sun's influence and the space that lies beyond it. The exact location of the heliopause is not fixed and can vary depending on the strength of the solar wind and the density of the interstellar medium. The Voyagers, by crossing this boundary, have provided the first direct measurements of the region beyond the heliopause, offering unprecedented views into the nature of interstellar space itself. NASA has emphasized the importance of the data provided by the Voyager spacecraft, noting that the mission continues to yield fresh knowledge about the nature of interstellar space. These findings are not only enriching our understanding of the immediate space around our solar system, but also contributing to broader questions about the behavior of stars, the interstellar medium, and the ways in which different star systems interact with their environments. The data being sent back by the Voyagers is helping to shape a new era of space exploration, one that transcends the boundaries of our solar system and ventures into the interstellar frontier. The information being gathered by the Voyager spacecraft is helping to answer some of the most fundamental questions about space, such as the composition and structure of the interstellar medium, the dynamics of the solar wind as it interacts with this medium, and the behavior of cosmic radiation in interstellar space. These insights are crucial not only for understanding our own solar system, but also for gaining a deeper understanding of the broader universe. For example, understanding the dynamics of the solar wind and its interactions with the interstellar medium can help scientists better understand the environments around other stars, the ways in which their solar winds interact with their planetary systems, and the potential for habitable environments around distant exoplanets. The Voyager probes have also offered important insights into the broader context of space exploration. In an era when most missions are focused on the exploration of specific planets, moons, or other bodies within our solar system, the Voyager's journey into interstellar space represents a truly unprecedented scientific accomplishment. They are the first human-made objects to enter this vast region between the stars, and their continued operation and transmission of data are providing an invaluable resource for future generations of scientists, astronomers, and space explorers. The scientific community has long recognized that the solar wind and its interactions with the surrounding interstellar medium have important implications for the understanding of astrophysical phenomena. The Voyager spacecraft, by sending back detailed measurements of these interactions, have provided the first real opportunity to study these phenomena up close and in real time. These insights are not only enhancing our understanding of our own solar system, but are also contributing to our broader understanding of the forces at play in the wider galaxy and beyond. The Voyager's exploration of interstellar space has already rewritten many of the textbooks on space science. Prior to their arrival at the boundaries of our solar system, much of what we knew about the nature of space beyond the sun's influence was based on theory, indirect measurements, and simulations. Now, thanks to the ongoing transmission of data from Voyager 1 and Voyager 2, we have direct empirical evidence of what lies beyond the heliosphere, providing scientists with a much clearer picture of the forces that shape the space between the stars. And in a bold idea, experts are speculating that Voyager 1 might encounter extraterrestrial life by as early as 2029, a milestone that could potentially mark the beginning of communication between humans and alien beings. This speculation arises from several key factors, including the spacecraft's trajectory, its ongoing mission, and the growing interest in the search for alien advanced civilization. Voyager 1 is currently traveling through interstellar space, the region of space that lies between the stars, where the influence of our sun's gravity no longer holds sway. This marks a significant milestone in human exploration of the cosmos, as Voyager 1 is now venturing into a completely uncharted and unknown expanse of the universe. As it travels farther from Earth, Voyager 1 continues to send back data to NASA, though the signals it transmits have grown weaker over time. In fact, the spacecraft's communication system has been operating for much longer than originally anticipated, and it is expected to continue transmitting for several more years, though it will eventually cease once its power source is exhausted. The prospect of encountering extraterrestrial life is rooted in the idea that life, in some form, might exist beyond Earth. Given the vastness of the universe, with billions of stars and potentially trillions of planets in our galaxy alone, the possibility of life existing elsewhere seems increasingly plausible. While no direct evidence of extraterrestrial life has been found to date, scientists have discovered numerous exoplanets in the habitable zone of their respective stars, where conditions might be suitable for life to exist. This has fueled the belief that life may be more common than once thought, and that it is only a matter of time before we make contact with another civilization. Some experts believe that Voyager 1, given its current trajectory and the vast distances it is covering, could be one of the first human-made objects to come into contact with alien life. The idea of communicating with extraterrestrial beings is another factor that has led experts to speculate about the possibility of contact in the near future. While the vast distances between stars make direct communication difficult, the search for signals from alien civilizations, known as the Search for Extraterrestrial Intelligence, or SETI, has been ongoing for decades. Scientists involved in SETI have been listening for radio signals, laser pulses, or any other form of communication that might be transmitted by advanced alien civilizations. However, the challenge is immense, as the signals from extraterrestrial civilizations, if they exist, would likely be faint and difficult to detect. Voyager 1, however, is equipped with a golden record containing information about humanity, including greetings in various languages and images of our planet. This record was designed with the hope that it might one day be found by an intelligent alien species, providing them with information about who we are and where we come from. In this sense, Voyager 1 could be seen as a message in a bottle, sent out into the cosmos in the hope that it might one day be discovered by an extraterrestrial intelligence. While the possibility of Voyager 1 encountering extraterrestrial life in the near future remains speculative, there are several factors that make such an event plausible. One key consideration is the vastness of interstellar space and the likelihood that there are other civilizations out there. Given the sheer number of stars in our galaxy alone, estimated to be around 100 billion, many scientists believe that the odds of finding another intelligent civilization are relatively high. Additionally, the discovery of exoplanets in the habitable zone of their stars has only increased the likelihood that life could exist elsewhere in the universe. Some of these exoplanets are located in star systems that are relatively close to our own, making the prospect of contact with extraterrestrial life more feasible. The possibility of communication with extraterrestrial beings raises a host of intriguing questions. How would such communication occur? What form would it take? And perhaps most importantly, how would humanity respond to the discovery of alien life? These questions are difficult to answer, as they involve unknowns that go beyond the realm of current scientific knowledge. However, the idea of encountering extraterrestrial life raises profound philosophical and existential questions about our place in the universe. Would contact with an alien civilization change our understanding of life, intelligence, and the nature of existence? Would it lead to a new era of cooperation and collaboration, or would it spark conflict and fear? These are questions that humanity will have to grapple with if and when we make contact with extraterrestrial beings. Despite the challenges and uncertainties involved, the possibility of encountering extraterrestrial life by 2029, whether through Voyager 1 or some other means, represents a momentous occasion in the history of space exploration. If such an encounter were to occur, it would be one of the most significant events in human history, reshaping our understanding of the universe and our place within it. It could mark the beginning of a new chapter in our exploration of the cosmos, one that involves not just the discovery of new worlds, but also the discovery of other forms of life and intelligence. In many ways, the search for extraterrestrial life is a reflection of humanity's deep-seated curiosity about the universe and our desire to understand our origins and our future. For centuries, humans have looked to the stars with wonder, imagining the possibility of life beyond Earth. Now, with advancements in technology and space exploration, we are closer than ever to turning that imagination into reality. Voyager 1, as it continues its journey into the unknown, serves as a symbol of humanity's ambition to explore the cosmos and its quest to find answers to some of the most profound questions about our existence. Whether or not we will encounter extraterrestrial life in the near future remains to be seen, but the possibility is enough to inspire excitement and wonder in the hearts and minds of those who look to the stars. Moreover, the potential for communication with extraterrestrial life would have far-reaching implications for science, philosophy, and society as a whole. The discovery of alien civilizations could revolutionize our understanding of biology, technology, and even the very nature of consciousness. It could lead to new scientific discoveries, technological advancements, and a deeper understanding of the universe itself. The philosophical implications of such a discovery are equally profound, as it would challenge many of our most fundamental beliefs about the uniqueness of human life and the possibility of other intelligent beings in the cosmos. For some, the discovery of extraterrestrial life could offer a sense of connection with the broader universe, a reminder that we are not alone in the vastness of space. In short, more data from Voyager over the next few years may hold crucial information to the origins of the hum. The findings are already remarkable considering the space probe is functioning on technology from the mid-1970s. The craft has about 70 kilobytes of computer memory. However, do not expect too much. The Voyagers outlive their purpose, but they will eventually die. Power levels are so low that only half of their instruments kept on. That's why, over the years, scientists have been convening to discuss how best to keep the spacecraft running for as long as possible, shutting down systems as needed. As of now, Voyager 2 now has 5 remaining functioning instruments, and Voyager 1 has 4. All are powered by a device that converts heat from the radioactive decay of plutonium into electricity. But with the power output decreasing by about 4 watts a year, NASA has been forced into triage mode. 2 years ago, the mission's engineers turned off the heater for the cosmic ray detector, which had been crucial in determining the heliopause transit. Everyone expected the instrument to die. The last 2 Voyager instruments to turn off will probably be a magnetometer and the plasma science instrument. They are contained in the body of the spacecraft, where they are warmed by heat emitted from computers. The other instruments are suspended on a 43-foot-long fiberglass boom. So, how much longer might the Voyagers last? Well, if everything goes really well, maybe we can get the missions extended into the 2030s. It just depends on the power. That's the limiting point. However, even after the Voyagers are completely muted, their journeys will continue. In around 16,700 years, Voyager 1 will pass by our closest neighboring star, Proxima Centauri, with Voyager 2 following behind 3,600 years later. Even then, these spacecraft will not cease their cosmic wanderings. For billions of years, they will continue to circle the galaxy, far beyond the point where our sun has burned out and the heliosphere has vanished. Long after humanity is gone, the Voyagers will remain out there, undeterred by the passage of time, quietly drifting in the vast expanse of space. The potential for them to convey a final message exists, but it will not be through radio signals, and if anyone or anything receives it, it will not be human. The message carried by these distant travelers is not one of electronic communication, but but rather one embedded in a more enduring form, two gold-plated copper records, known as the Golden Records. The creation of these records was no small task. A committee led by renowned astronomer Carl Sagan spent over a year selecting the materials to represent the story of life on Earth. The records contain a wide range of information, from photographs to sounds, that illustrate the depth of human existence. Among the most iconic elements are the musical selections, often referred to as the mixtape for the universe. While music is certainly an essential part of the Golden Records, it is far from the only significant aspect. One of the unique sounds encoded on the records is the sound of humans making stone tools, or napping. This is the oldest and most enduring form of technology ever created by humans, used for more than 3 million years. The rhythmic clink of stone striking stone to produce a sharp-edged tool was a familiar sound for much of human history, representing the foundational technology that allowed our ancestors to survive and thrive. It's a reminder of our distant past, when technology was built from the Earth itself. The images on the Golden Records also reveal insights into the human experience. Among the 116 photographs is one depicting a black scientist in a laboratory, hunched over a microscope, studying the microscopic world. Her elegant earrings cascading from her ears became the subject of some debate during the planning process. Would an alien civilization recognize jewelry as a human cultural artifact? Alongside this image is a photomicrograph of dividing cells, meant to convey that humanity possesses an understanding of biology and the scientific methods of exploration. Perhaps most strikingly, the records also contain spoken messages in 55 different languages, ranging from ancient tongues like Akkadian and Hittite to modern languages spoken across the world. In these messages, the most common themes are peace, friendship, and goodwill. One of the greetings, spoken in Portuguese by Janet Sternberg, simply says, "Peace and happiness to all." The diversity of languages and the universal themes of peace reflect humanity's deep desire for harmony and connection, even across the cosmos. Despite the incredible treasure trove of cultural and scientific information contained on the Golden Records, the true significance of the Voyagers lies in their position in space. In essence, they are physical markers of humanity's reach beyond the Earth, the first tangible evidence of our species attempting to communicate with the wider universe. Their journey signifies the limits of human exploration, the boundaries of what we have been able to accomplish in our quest to understand the cosmos. When the Voyagers fall silent, it will mark the end of a significant chapter in our interaction with the universe. Telescopes and other forms of remote observation can only show us so much of the universe. There is no true substitute for physically sending something out into the unknown, a message not just of data, but of humanity itself. The question remains, who or what will follow in their footsteps, continuing the journey beyond the stars? That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.